a very warm welcome to all of you. Well, if I talk about, what we have been doing, I'll just rush up with what we have been talking about. We have talked a lot about your oxygen family. We have started with that. We have been doing the P block elements. If I talk about the last class, I told you how to draw the different types of oxides. I told you what to do, we discussed about the oxygen family, particularly we talked about the anomalous behavior. We have talked about the different types of oxides, we have talked about the different types of reaction. That's what we always do. So today what we have to do is, we are going to take up the particular case of your ozone, where we will study how ozone that leads to the preparation. Of course, that's what we have been doing. We have been talking about the preparations, we have been talking about the physical characteristics, and then we come to the chemical properties, right? So of course we would be discussing that, we would be leading on to that, but before that we have to talk about a small topic, I'll say, just a subtopic that we need to discuss, that we even started. When in the last class I was teaching you about the oxides, I was teaching you about the characteristics of oxygen. I ended up at a point where I gave you some reactions, and then I said that we are going to talk about the particular preparations as well, right? So for today, give the heading for your case of oxides. Now, there is one specific, I'll say, particular characteristic that we observe, that oxide, if I talk about them, what basically an oxide is, that is, when I'm reacting my oxygen with either my metal or my non-metals, or depending on whether it is a metalloid. So, based on that, what we would be doing, we would be discussing the classification of your oxides. That would be, that would go like, your first is acidic oxide, then we will talk about your basic oxides and the amphoteric oxides. Now, these three are the most main topics, I'll say. After that, of course, we will discuss about some other parts as well. We will discuss about your superoxides, your dioxides, and even some of the cases of other forms where I talk about the neutral oxides. Right. So, we will of course take each one of them step by step. So, let's start with the first one that I say is my basic oxide. Now, when I say that I want to talk about a basic oxide, what does that mean? Well, if I talk in a layman's language, if I talk in terms of a very basic term, what do I mean? That means if I am taking up a particular element, that too, I'll say is going to be a metal, because I am discussing about the basic behavior. Now, this is how you are going to classify your periodic table. You have to do that only and only, if I draw up my periodic table, I know this thing, that first two divisions that I give to my alkali metals and my alkaline earth metals, right? We have talked about that. Then after that comes the portion where I have to discuss about my known metals, right? And then somewhere in between, I take up my transition elements and all other things. So what I am saying right now is, I am saying that I want to discuss about my basic oxide. What does that mean? That means that if I react a particular element with oxygen, that would lead to the formation of a base. That means that if I am taking up some reactants and the product that I get is basic in nature, that would be considered as my basic oxide, right? So, same way I can say for acidic oxide as well. That means that in that case I would be taking up such elements which on reacting with oxygen are going to convert to an acidic oxide, right? Of course, we are going to take up each one of them step by step. First of all, let's write down for our basic oxides. As I said, what did I say? The compounds on reaction with what? What did I say? I said reaction with oxygen lead to the formation of a base. That leads to the formation of base. Now, of course, I have done so much of chemistry, if I am in 11th or 12th standard, I have done these terms so well that it's like ABC for me. I know what an acid is, I know what a base is. So now I am saying that I am talking about something that converts to a base. That means if I take up an element, let's assume I take up magnesium oxide, or if I take up Fe2O3, or as just I said, what did I say? I said that I have to take up a metal, oxide of metal, which on reacting with water is going to convert into my acidic oxide. That's what I have to say. So what happens is, now I am saying I want, I am going to lead to the formation of a base. I have to react it with water, right? I know this thing that, if I have to react a particular compound, I have to react my oxide with water. The general tendency or the general reaction which goes is that lead to the formation of what? Of course, that is going to lead to the formation of a hydroxide, right? So when I am reacting my magnesium oxide with water, that would lead to the formation of magnesium hydroxide. Same way, if I say I have taken iron oxide, that leads me to the formation of my ferric hydroxide. Now what do I say? I say that this is basic in nature. That's what I have seen. Why do I say that? Well, that is simple, because the elements that I have taken up, they are metals in nature, and whenever I am reacting a metallic compound, I am reacting a simple metal, the one which has electropositive tendency, on reacting with simply water, that is going to give me a hydroxide. And this is the particular characteristics of this hydroxide of mine, which is basic in nature, right? Then I say something about your acidic hydroxide. Now if I want to talk about the acidic hydroxide, what do I say? In the previous case, I said, I have taken up an element, I have taken up an oxide. I am bringing about a reaction with water. I have my reaction flask ready with me. What I have to do is just mix my compounds and I am getting a product. Same way, this time, I want to talk about the acidic case. Acidic case, that means that if I am going to react something, if I am going to put up something into my reaction flask, that would lead to the formation of such an oxide or such an hydroxide that would be acidic in nature, right? So for that, what you are going to need? You are going to need something which has already a non-metallic tendency, right? And if I want to know, if I discuss with you, if I ask you, even in the previous case when we talked about the nitrogen family, what did we say? We talked about the cases of the different types of oxides that are present, right? And now I want to know about my acidic case. So if I take up compounds like, if I take up CO2, if I take up SO2, sulfur dioxide, or some another compound like oxide of phosphorus, that would be my P4O10. And what do I have to do? I have to react my compound with water, right? That's what I have been doing till now, right? So what do I figure out of this? As I said, even mention into this one that we have taken up metallic oxides. And these are the cases, of course, we all know that these are the cases of non-metallic oxides. So we have non-metallic oxides, right? That's what we have. Now, as I said, that the compound, as in the previous case, well, of course, this is of water because we have written the right reaction, but we didn't write the right word. So I say acidic hydroxides. If I want to write the definition of that one, I will say the compounds which on reaction with water, what happens? On reaction with water, they are going to lead to the formation of an acid, right? So I say reaction with water lead to the formation of an acid, right? That's what I say. Now, if I have a non-metallic compound, right, and I have my reactant, I have my water, and what did I just say? I just said that this is the compound, this is the situation which on reaction is going to lead me to the formation of an acid. Now tell me one thing, of course you have done this and you would remember that pretty easily. If I talk about an acid that is made up of your carbon dioxide or carbon, what do you see? We know that my carbon that leads to the formation of an acid which is my carbonic acid. Of course, I know that thing. Same way, if I want to talk about my sulfur, that leads to my sulfuric acid. My phosphorus, that creates a phosphoric acid. So, if I have to write the reaction, I'll just say, I'm getting H2CO3, H2SO3. Well, of course, this is not sulfuric. You can create even a sulfurous acid or sulfuric. That totally depends on the reaction conditions that I'm going to provide, right? This was phosphorus, the oxide of phosphorus that would lead me to H3PO4, right? So, this way you would be able to write down the reaction if you know the conditions. Now, you know the thing, what you have to do is you have to just take up the oxide of the particular element. Initially, when I say that, I'm taking up an oxide of non-metal, then, like in this case, I'm taking up non-metal, right? Here I took up the metallic oxide. And if I am reacting, I am getting a base and acid respectively. Now, one reaction I will say, because this one that generally comes into your paper, you know that thing, that because P block elements that totally revolves around your reactions. So, I will suggest this, try to remember this one, because question generally comes from your acidic oxide case. One or two reactions, if I say, let's take up this reaction. If I talk about the nitrous case, the case of nitrogen, if I have the oxide of nitrogen, what do I see? I see that on reacting with water, I am going to get HNO3, right? Basically, what you have to do is, why we are doing it, so that you can get practice of the fact that you have to convert the oxide to the respective acid, right? Another one, if I say, the oxide of chlorine, Cl2O7, I know this, I am reacting it with water, going to lead to the formation of HClO4, right? And of course, the same thing, I have not balanced the equation, that is your thing, you are going to balance the equation and you are going to write that, right? So, this would be all, like this is more than enough if you want to discuss about your acidic oxide and your basic oxide, right? Then I said something about the third case. I said something about the amphoteric oxide. What did I say? Now, if I take up my third case, that is amphoteric oxides. Now, of course, that means that these are the compounds which on reaction with either acid or a base, either I am reacting, first thing I know, I have to react it in the presence of water, right? Now I am taking up an oxide and I am bringing about the reaction. Even in the case of acid, this reacts, the case of base, it reacts as well. That is the one which can be prevalent in both your conditions. That is, it can give you an acid, it can give you a base, right? So, let's write that down. I say the compounds which on reaction can act as both acids as well as bases, right? That's what I said, that's what we have to do. Then if I talk about the particular reaction, I know one thing, that I have been talking about the amphoteric oxides. Whenever I say amphoteric compound, of course, aluminium is the first thing that comes to my mind. I know that can exist as hydroxide, that can exist as oxide, simple Al2O3 or AlOH thrice. Now, if I write the particular reaction, I have the respective oxide, right? Now what I would do is I am going to react once in the presence of an acid and in another condition in the presence of a base. So what happens when I am doing that? If I am doing it in the presence of acid and of course water I have to take up, because that is the essential requirement, that is the basic thing that I have to do, because if I am not taking up the water, I won't be able to convert it into my hydroxide. So the second one, as I said, I take up a base. The most common one that we always talk about, that is nothing but my sodium hydroxide. So what happens in this case? Now of course, as I said, that I've changed the conditions. If I have changed the conditions, of course, some different products should be formed as well. But the point that has to be noted here is that now this particular compound that has a tendency that it can prevail in the presence of acid and it can prevail in the presence of base, right? So if I write down, when first of all I am doing the reaction in the presence of an acid, this is going to give me a hexa aqua compound. A neutral compound. Of course, we talk about that into your coordination. We will be doing that and you will have the total clarity about this. And right now, you don't even need to write down the names and all. You just should know the product. In the presence of base, I say that I am going to get hydroxide. Now, of course, if I talk about the charges, 3 plus that I have, and in the outside, 3 moles of sodium. Well, of course, that's what I'm going to need, because if I want to bring about a reaction, I have to do that. I have to write down. So, with this, of course, if someone now asks you, if someone says that you have to give a particular reaction, you have to talk about the oxides that are available, you would be able to do that, right? So, what we have done is, for case of basic, you remember that thing, going to convert into a base on reaction with water. In presence of acid, that is going to convert into an acid on reaction with water. Then amphoteric, we said, that has a condition where both are present. Both can act, both are going to lead me to the formation of a particular compound, right? Then if I take up some of the other cases, the fourth one that we see is a neutral oxide. Now I say, I have something called as a neutral oxide. So what do I observe? What do I have when I am talking about the neutral oxides? That means these are the compounds, such compounds which are not going to bring about, which are unaffected by the fact whether the reaction is happening in the presence of acid, whether the reaction is happening in the presence of base. That means somewhere the presence of these compounds is going to be unaffected, is going to lead to no change, right? So I can simply write down, in short, if I say these are unaffected by acid or base. Well, of course, example, if you want, you can write down water, that is your universal solvent. You can give for your NO or CO. So compounds like this, that you can simply give. This is, I wouldn't say that this is much important as well, but of course we have to do, because that is into our classification, so we should talk about that, right? Then I talk about the next one that I have. The next classification that I have is for my peroxides. Now, what exactly do I mean when I'm talking about the peroxides? Now, I have talked about one thing frequently, that peroxide, that is something that is going to have oxygen and oxygen linkage, right? We have talked about that, we have done that. Same way, now I am saying I want to discuss the case where I am talking about the particular element. I want to talk about that gas, I want to talk about that liquid. So I should know that how to prepare that, right? So if you recall the last class where we were talking about some of the preparations that we did. In the preparation of a dioxygen, I gave you a reaction where I reacted sodium peroxide with an acid, with concentrated sulfuric acid. Now that was a reaction that led to the formation of a peroxide. Well, of course, we have to give the same reaction into this one as well. So let's see that. I said that I am reacting my sodium peroxide in the presence of your concentrated sulfuric acid. Now, of course, you should remember that what did it lead to? It led to the formation of sodium sulfate and my hydrogen peroxide. So what exactly I refer? That means if I want to talk about the peroxides, I can say that those compounds which on reaction with a particular acid with a particular base lead to the formation of hydrogen peroxide, right? Same way I can give another reaction if I talk about the peroxide of barium. What do I see? Same way I am reacting it with my concentrated sulfuric acid, that is going to lead me to the formation of my sulfate as well as hydrogen peroxide, right? And that's what we have been talking about. That's what we have to write. I said that I have to bring about any particular reaction, I have to say any particular reaction, any particular condition that would lead me to the formation of this, right? Then if I say that I want to talk about your another category, that would be your suboxides. Well, for this case, I'll say the reactions, we do not need any reactions, only and only examples would be more than enough for you. So that's what you have to do. That is nothing but but I'll say the elemental state when they are happening into the different types of valency. Like if I talk about a case where I say I have a compound called your C3O2, or so what would I say? Oxygen that is not present into its normal form. So if I write C3O2 or your Pb3O, right? So simply what do I observe is that these are the particular cases where the element that we see, that we talk about into the normal valency, that is not present, that is happening, that is going to react into some different format, right? So that's how we can talk about your suboxides as well. If you want, like, you can write it down as well. The thing that I said, that is nothing but the valency of oxygen that is not normal, that is different from what I expected. That's what we have to do in the case of suboxide, right? Now the same way, after these one, we have to discuss about some of the other cases of oxides as well. You know, I would talk about a dioxide. That's what we have to do, and that would be of course lead to almost the end of the discussion of the different types of oxides, right? So write down the next thing that we have to do is we are going to talk about your dioxides. So I write dioxides. So tell me one thing, you know, when I talk about the particular case, what do I mean when I say dioxide? Of course, I used to say a word dioxygen. What did I mean? I meant that I am talking about the case where oxygen that is not in the elemental form, not single O, that's not how it is present. It is present as my O2. So what do I have to do? I am going to, you know, take up any particular compound of mine. I am going to take up any particular oxide. Generally, we take up the example of your MnO2. That's how we reacted with your different acids and see what are the compounds that we get. So if I say I am reacting MnO2 in the presence of once with HCl, and another case that I see, that would be my H2SO4. So what do I get? Now of course the same thing that we have been talking about, we have talked about the displacement reactions a lot, right? So I know this thing, if I have to react it, I know what do I have to do is I am going to displace my magnesium, that is going to react with my chlorine, and the other elements, they are going to combine sidewise as well. So what do I get? I get magnesium. Now the first one is a chloride. I get MnCl2 with the release of chlorine with the formation of water, right? So what exactly do you see in the case of dioxides is you are going to get the corresponding element. Apart from that, the corresponding gas that is released on reaction with the particular compound. That is the beauty of dioxides. That two things I am getting. I am pretty sure about the fact I am going to get the corresponding gas, I am going to get the corresponding element, right? Then if I talk about the next one, what did I say? I say again the corresponding gas, but this time I am reacting it with my sulfuric acid. right? That's how I'm reacting it. So this time I know, of course, this can't lead to the formation of chlorine. This is going to lead to the formation of my oxygen and the formation of my water, right? That's how I can get that. That would be about a dioxide. So what did we do? We take up the particular element, we react it with the corresponding acid, going to lead to the formation of the corresponding sulfate, of the corresponding chloride, along with the release of particular gas, right? That's what we have done. Now, if I talk about the last category, sometimes they even ask about that. That would be the mixed oxide. Now, what do you do in that case? I don't have to do anything as such. What I am going to do is, I have to react my oxide with a particular acid, and that is going to lead me to the formation of a compound that would be available in different oxidation states, right? How do we do that? Let's see. I say that I have to react my particular oxide, and that too in the presence of an acid, right? I am getting this. Now, that would lead me to the formation of compound, that is going to lead me to the formation of lead. I get lead in this state, and another one where I have the nitrate, right? I get this one. Now, what do I see? If I have my lead, with a combined form of oxide, if I have one time I have it with nitrate, what do I see? I see that the valency, that is going to, if I am going to calculate the oxidation state, I am going to observe, as you know, we calculate it. If I take up x minus 4, that is 0. The valency in which this is present is plus 4. The valency, if I talk about this one, that would be my plus 2. So what do I see? I can simply write, if I want to write, I can simply say compound in different oxidation state. Right, that's what we have observed in this case. And that's all that we have to discuss in the case of oxide. Now, what do I say? I say when I am talking about a mixed oxide, I am going to bring about the reaction of the corresponding oxide with the nitrate or whatever I want, and I am reacting it with my, I have done the reaction that is going to lead me to compounds, to such compounds in which it would be available into your different forms, right? So this way we would be able to do that as well. Another, if you want, you can write down, not much prevalent category as such, but if we want, we can, let's discuss about that as well. Let's just write down the last one that we have. That would be the case of your superoxides. Now, of course, if I want to talk about superoxides, that is something in which, now I can see the word, I see the word super, I see the word oxide. Of course, my oxygen, that is not available into the normal valency again this time. What happens? What happens is, these are the compounds, such compounds where I observe the valency of oxygen to be plus 1. That's how I balance out the equation, right? If I want to, find out the valency, I know that potassium, that is present into my plus 1 state, oxygen. But this time I have to calculate for oxygen, and I am going to see that is not going to be a minus 2. Now, if I want, you can even write down one particular reaction for this one as well. When the superoxides, they react with water, they generally lead to the formation of a hydroxide. So, if I write down for this one, let's see, if I say, I am reacting my superoxide, that is happening with my water. What do I get? I say that on reaction with water, this is going to lead me to hydroxide, this is going to lead me to the evolution of a particular gas. So, if I want, I can simply write hydroxide is formed. Along with that, if you want, as I said, as I always say, the corresponding gas, that's what we are talking about. So, this would lead me to the formation of hydroxide, to the formation of peroxide, along with my oxygen, right? So, what do I conclude out of it? I say that whenever I have to talk about my superoxides, I have to say that these are such compounds which on reaction with water are going to lead me to the formation of my hydroxide, to a peroxide along with oxygen, right? And if I say what is the corresponding hydroxide that I get out of potassium, what would you say? Well, of course you say that ma'am, that would be potassium hydroxide, simple that is. And the peroxide, if I talk about, I have my hydrogen, I have my oxygen, simply hydrogen peroxide, that's what I am getting, right? And oxygen is the corresponding gas. So if I want, if this way, now you know, if someone is going to ask you, if someone says any type of oxide, you know, different types of classification, I hope you would be able to do that. And if I talk about your exam, generally the questions that you would see, they are not going to be asked that write down the reaction for a superoxide or write down the reaction for a peroxide. No, they are not going to ask that way. We have done it so that we would be able to give an example according to how we want, according to what we have done. Right. So, all that you should know is the different classification, the different reactions or the procedures that they are leading to. That which particular compound would lead to the formation of an oxide, which particular compound would lead to the formation of acid, or the compound that will lead to the formation of a peroxide. Right. So, I hope that you would be able to do that now, you would be able to classify. Now, the next thing or the next topic that we have to discuss is that would be your case of ozone. That's what we have to talk. So, give the heading for your ozone. Now, we hear about this thing a lot, you know, we talk about it a lot, we know what ozone is. Whenever I am saying that my whole earth, that is protected with a thin layer, that protects the harmful radiation of earth to come down, right? And what happens when the radiations, they fall onto the earth, that can burn my skin, that can cause cancer, that can cause anything. Well, of course, that's not what we are concerned with, because that's not our subject that you are going to study into a biology. What we have to study is the composition of that layer, the reactions that are happening with that layer, how the layer is protecting us, and you know what particular consequences it can lead to. So, if I have to talk about your ozone, I know one thing, that if I have to write down what does the ozone mean, that is nothing but simply your O3. So, if I write, I can represent it by O3. That's how I represent my ozone. Now, I know one thing, that ozone, that is going to, okay, first of all, let's talk about its composition, or you know how it looks. What do we say? I know that if I am able to prepare my ozone commercially in the sense if I am able to make it into my lab, I am going to observe that ozone is something that is a pungent smelling gas, which is deep blue in color. This is not colorless, of course, like the oxygen that we talk about. This time we observe a complex which is deep blue in color, which has a pungent smell, and you know the smell of a rotten fish. That's what you feel about it. So, we can say if I want to classify, if I want to differentiate my oxygen from my O3, I would be able to do that, because now I know that is odorless, but this time I have a gas, this gas of mine that has the fish rotting smell, right? So, that's how I would be able to do that. Then if I write down the reaction, the main reaction that we observe, the reaction of ozone in the presence of a proton and electron, what do I see? Now, this is going to lead me to the formation of oxygen and water. That's how ozone reacts, that's how the presence of electron that affects my ozone, and that's how I can get oxygen out of it, right? Now, you know, if I talk about the main things, the main question that arises in the case of ozone, that you have to discuss about some of the particular reactions, that how it reacts with the fluorides and what are the characteristic properties. So, that's what we would be doing. So, let's start with each one of our reactions. So, if I start with my first reaction, if I want to first of all talk about the preparation, that's what we do, that's what we generally discuss, how we lead to the formation. So, I say that I have a formula, you know, I have the particular condition that I can bring about a reaction between my fluoride and water, and that is going to lead me to a particular compound which is called as your ozonized oxygen. Now, let's see how we can do that. Now, I say I am reacting my fluoride in the presence of your water, right? First of all, the basic condition I have given, I know how to do that. Of course, that is going to lead me to the very famous, the most, I'll say, the most acidic compound that we see, that is nothing but my HF, right? We get that. So I can say I get HF plus my oxygen, right? Now what do I do? Next time I say I have to do the same reaction. I have to bring about the same reaction with same reactants, but the conditions, the number of moles that I am using is going to change this time. So what do I do? Now this time again I say I am reacting it in the presence of water, but in the last case, as I said, I have my 2 moles. This time I just take up 1 mole. I take it up as F2. What do I get? I am going to get my HF along with my O3. Now what is this? I have started the same reaction. I have taken up the particular reactants, but what I am leading on to is different compounds. Now if someone asks you, now this is the thing, because generally you are going to see the question that how ozonized oxygen is formed. Ozonized oxygen, that is a term that leads to that we use when we are using the particular reactants, the same reactants but with different number of moles. That's what I have done. In the first case I have taken up 2 moles, in the second case I have taken up 1 mole of fluoride. So what it is, as I said, I say ozonized oxygen, right? That's how I can say this. Now, before we head on to the other reactions of my ozone, I am going to discuss one particular thing, that since we were just talking about the oxides, we didn't discuss that thing, that comes to my mind, that just few lines about that. I said that my non-metals initially, like if I talk about the initial ones, if I am moving along a period, how do I move along a period from my left to right? If I go, I say that I am moving from the metallic state to the most electronegative element, right? That's how I move. So if someone asks me, someone says that if I want to talk about the particular oxide and I want to know what is the nature of the corresponding oxide, what would I say? Alright, you know what, do one thing, put up a star, because this is not intermixing of this topic, this is a different subtopic, like few lines that we need to do before we move on to our topic, right? So I say moving along a period, I have to discuss the strength of oxides, right? I am saying I am going from my lithium till the case of my fluoride. What do I see? Now I know one thing, that the first compound that is going to be highly basic in nature, so I will simply say that the acidic strength that increases on moving from your left to right. The acidic character is increasing. Why it is increasing? Because as I said, when I am reacting my oxide, the oxides of my first 2 groups, my alkali metals and my alkaline earth metals, they are going to lead me to the formation of a base, right? I know a base is formed. I am moving towards it, I am moving towards the end. These elements, now these elements are going to lead to the formation of an acid. So what do you conclude? Of course, if I ask you a basic, like common sense question, I am saying these are the bases, these are the acids, which one is more acidic? Well, of course, even a layman, anyone would be able to answer that if I am moving from basic to acidic, of course, this is the side that is going to weigh heavier. This is going to be more acidic, right? So this way, if you want, you can write that down. That's what you have to write. Moving along a period, the strength of oxides or the acidic strength that increases. I simply write it down as lithium oxide till my, let's just take a water. I'm discussing till the oxide of water, oxide of oxygen family. So I say that acidic strength increases. Right? Same way, if I have to move downwards, I am moving down the column, I am moving down the group. Now my size is increasing. This all I have discussed with you in very detail when I was giving you the physical properties. So I am not going to do that again. But I know this thing, that because the size is increasing somewhere, the basic character is increasing due to the addition of new shell. Well, I am writing it down again just because so that you can refresh the fact that we have already done, that we have already discussed. So, I am not going to explain that. For that, you have to move back to your pages in case you don't remember that. So, I can write that moving downwards, moving down the group, if I want, I can write in terms of acidic strength, because acidic strength, that is decreasing, but my basic strength is increasing. So, let's do one thing, because we have discussed in terms of acidic strength. Let's write it down as your acidic strength only. I say acidic strength, well, the spelling, of course, that is strength. I also do that sometimes. That is, moving down, the acidic strength decreases, right? So, if someone asks you, if someone says how to distinguish between the column, between a group, you would be able to do that. All we have talked about till now, I have just given you the preparations. I am going to discuss the whole thing, but that we are going to do in our next class. Till then, as I say, what you have to do, you have to go through the topic, you have to go through the lecture, and just take care of yourself and keep studying, and we will meet again. Till then, take care and bye bye.